Hello? Yeah, we did it. Hello. Hope everyone's doing all right. Oh, gotta tilt this. Tilt it. Tilt it. Hello. Hope everyone's doing all right. I'm doing all right. I got some tea anyways. I'm feeling okay. Feeling better than last stream on Monday or Sunday. I've been having thoughts about the Bamboo Labs printer. Hey JD Silva, how you doing? I have thoughts about the Bamboo Labs printer. I got a P1S, probably a week ago or something. This is only going to matter probably to people who are 3D printing nerds, but I guess I have some gripes. Overall, it's fine. It shakes pretty violently. It is fast, but it also is sort of lightweight, because it's made of all plastic. So I don't know what the X1 carbon is like, the higher end one. Hey, Cooper. But the P1S shakes, not like a lot. I used to have a printer for back when my parents had this, or Pentium 1 Gateway, and it was on a little stand. I wouldn't really call it a printer stand, but it was the size of the printer, so it was the printer stand. But every time that printer printed, it was it went like this. I remember that pretty well. Actually, that was back around the time that I learned about Wikipedia, and I had to do a project or something, and I wanted to print off the Wikipedia article for the whatever project, and it was 50 pages, and I was late for school, and I couldn't print the whole thing because it was just taking so long. It was not pages per minute, it was minutes per page. So anyways, this is fun times. But because of that, that's not normally a bad thing, but because of that, I actually kind of mentioned it last time, delicate prints, they tend to fall over. And I don't necessarily, it could be a combination of, I did actually wash the build plate. I have the textured PEI bed. I did wash it with soap and water. So it's possible that it was because I was printing with, I tried with both ASA and PETG, because I wanted to print one of those, well, the Ashita stand first of all, but that had a really delicate, less, half a centimeter little peg thing that fell over, and that kind of ruined a print. But also I printed one of those poop chutes, the things for the AMS, the little swoopy thing that makes the poop thing go around the corner. Hey Belmont, I tried printing one of those, and I didn't print, oh shoot, I can't remember his name. Kaitor. Kaitor has one that doesn't need any supports, and it doesn't have this little. The one I printed had a little support. Not little. It was like an inch. It had a little cylinder kickstand, I guess. So it's a ramp thing, but then it has a support little stick going up it. And the support thing fell over. It was pretty big. It's an inch. And I have to assume it was just because, well, the problem is that print was so big that it took up pretty much 100% of the bamboo, the print bed. So I couldn't really do a brim. And normally I print with brim. I print with my Voron, I print with brim a lot because ASA and ABS tend to warp, even with preheating and stuff. So it could have been that. It could have been, oil on the new print bed. But then I also had some ASA stick to the bed. So the first thing is I don't necessarily like how fast it is, and it's adjustable, right? You could change the settings in the slicer. But it's supposed to be, that's the getup is it's tuned out of the factory, right? So for most things it's probably fine. And actually I printed this bracket in PETG. So my X1 shakes like it has epilepsy, but it has a setting to calibrate for it. Right, so right. Just because it shakes doesn't mean it's going to print bad because of, not pressure advance, what's the other one? the one that calibrates for the shaking. The P1S has that as well. So it doesn't print bad. The problem is just it could shake loose parts, and if things need support, things might need extra support. I don't know. So I'm still learning that sort of ecosystem and how to do it, how to use it. The thing, I guess, the most that I don't like about it is the fact that there is no seemingly easy way to adjust the Z offset. I know it's supposed to have a calibrated Z offset, but and if you don't know what I'm talking about for Z offset is the distance between the bed and the nozzle. So you are supposed to be able to put in what build plate that you have, the filament that you're trying to print, and then it has a bed mesh probe, so it can bed mesh the bed. And then it has a baked in Z offset, which is the distance between the nozzle and the bed. But the problem is that's not for most of my filament. I'm not printing with the Bambu Labs filament. I'm printing with just generic filament. So they have a generic setting, and not all filament is the same, even if it's the same type of filament, right? So PLA one brand is not the same as PLA of a different brand. So even though it might be good for one brand, the generic profile, it may not be good for another one. So there's no easy way that I've seen. Well, to be fair, it's not really easy to set a Z offset in, well, you can do baby stepping easily in Clipper, which is the system that the Voron uses, which is basically you're live adjusting the height of the nozzle as it's printing. So you can kind of see how the adjustment of Z, you can actually see how it's going when it prints. So you can make it lower or higher if you need to. You can't do that with the Bambu Labs printer. Input shaping, yeah. That's the vibration compensation thing. So the P1S does that too. So that's the biggest thing I don't like is you can't baby step. You can add an offset, a Z offset, so you can change it, but you have to know what it needs to be every time that you start a new print, which is not terrible. I mean, what I do with my Voron, every time I get a new filament, you tune all these different parameters, and one of them is the Z offset. I even have we'll get started with the thing in a second. I even have a auto Z offset script, which means that my Voron has it's called a Euclid. It's a little micro switch that is magnetized. It has a magnet on it, whatever, so that the tool head can actually go over and get the micro switch, and then use that to probe the bed. But it can also probe. There's something called the Z end stop, which is how the printer knows where the bottom of itself is. Like how does it know how far down it can go? It has a switch. So the nozzle normally hits that switch, and that's how the printer knows, hey, I'm at Z, or the bottom of Z. But it can also probe the Z offset switch with that micro switch. So because it knows the dimensions of the micro switch and it knows where the Z offset thing is, it can actually do the Z offset. It's supposed to be able to do it automatically, but it's still, like I said, it's not perfect, and filaments are different. So I still have to tune each one. All right, that's enough. There's nothing on the Bambu wiki. There might be. I don't know. I'm not sure. I didn't really look that hard. I kind of moved on. All right, enough of printers. I'm excited. I'm always excited, I guess. I'm excited for tonight because we could hopefully, the goal is to be able to boot DOS on the Micro 8088. Now, there's an extended goal of being able to boot or to be able to install DOS on the Micro 8088 so that we don't have to boot from a floppy. We can boot off the hard drive. So that's the extended goal. So how do we do that? Well, actually, you know what? Before we do that, I want to give a big shout out to PCBWay again. It seems basically I would not be able to do any of these projects without them. It's just, oh wait, I've got a thing. Hey, there we go. Yeah, without them I would not be able to do this, and because of them I have the opportunity to be able to do all these cool projects. And this is one of, I try to choose projects that I really care about, that I actually think maybe not everybody will care about, but I try. This Micro 8088 project is a very long project, right? It's if you're going to do this yourself, this is like a months long project, hours and hours of hand soldering if you're going to hand solder it. But it is very rewarding for sure. And yeah. So thanks to PCBWay. I want to give a quick shout out to their website. If you don't know about PCBWay, they are most well known for, I would say, they make custom PCBs for open source projects. So the Micro 88 and all of its expansion boards are open source. And if you have the files, you can have them produce them for you. So you don't really have to make your own PCBs, which is such a cool thing in let me cook. Such a cool thing to be able to do nowadays. Like 5-10 years ago, I would not be able to think about that. But they don't only do that, and I want to just give a shout out to their website. We're going to check it out for a second. How to do that? Oh, here we go. And that. Yeah. PCBWay. Oh wait, we don't need their logo on the website. They don't just have, so here's where you go to do the upload a Gerber, which is the file that you need from the open source project. They also have 3D printing services. So like if you don't have your own 3D printer, I talk about 3D printing a lot because I'm passionate about that. But if you don't have your own, they can produce the files for you. And all sorts of different filaments, from PLA to ASA and ABS and stuff. They even did my clear resin shell for my Ashita, which is one of the projects of all time. So this is a clear resin, pretty neat, with a urethane varnish, so they can do 3D printing stuff. And I know less about this, but they can do some injection molding stuff. I don't really know about the process of that, but you know, if you're a maker and you want to make a professional product, then. And they even have CNC, which is like cutting metal and stuff. So that's pretty cool. So I want to thank again PCBWay for sponsoring this video. Actually, my contact actually reached out to me to do a kind of shout out. They're actually going to be 10 years old next week. So that's pretty cool. All right. Done. Ski. All right. So let's look at the bench. Let's see what we've got so far. So last time we did this, where we worked on this project, we just basically populated both of these boards. And what is both of these boards? So on the left here we have a floppy drive controller, as well as a serial port for serial mice, which we're not really going to get into today, but that's what this is. So last stream I kind of began populating these boards. I finished it off stream between then and now. However, I did not put the ICs in, and so we'll kind of talk quickly. I want to kind of get quickly through that. Last time I spent a lot of time. So we're going to try to get kind of quickly through populating these pieces. But we also need to flash some kind of a floppy drive ROM. One thing that I can't remember who told me, but the difference between the IBM XT, which is what the Micro 8088 pretty much is a clone of. It's the 8088 sort of CPU IBM. The XT is what it's called. I guess the BIOS didn't have a floppy code, any floppy code. So your floppy controller actually had its own ROM to tell the BIOS how to do that. I didn't know that. I think that's true. I'm pretty sure. Versus like the AT and later, I think they had some sort of integrated floppy logic or floppy ROM stuff. So we will need to again write an EEPROM for that. So that's what there's an EEPROM spot in here. So we'll talk quickly about all those parts, and we'll do the flashing. Kind of like that's my main goal, is to get the floppy drive working first, because we should be able to actually boot into DOS. Hey, Alteracious has a new tagline, finishing off stream. Huh? I can't see, the stupid heart is in the way. Okay, so that's the main goal, is to finish the floppy controller. The stretch goal, I guess, is to work on the XT. And as you can see, the only thing I didn't populate with the XT so far is the compact flash slot, which I have. But I figured I would try to pull up the microscope and we could solder these pins and you guys could see that. I did print a bracket for it, but I guess my main goal is to try to see if it'll boot DOS. So let's see if we can semi-speed run that, because most of the stuff we already talked about with the CPU and the backplane stream. But you know, let's see what we got. So let me pull up the floppy controller GitHub. Let's see, is it ISA floppy controller? Is that gonna get us there? Nope. We need to add. Sergey. No, let's just go to Sergey's. Yeah, go to his GitHub. And then we gotta go to repositories. Scroll. FTC. Okay, that's why it didn't come up. Okay. All right, so let's go to the bomb. The bomb is going to help us finish off. Basically, let's see. Can we do this? Can we do this? This, and then can we add window capture? Is it window capture or display capture? Oh, there it is. Display capture. And then can we do this? That's my live streams too. I spend 2 hours talking and get one Game Gear recap. Yeah, well, Game Gear recaps are no joke. Oh, I see. It's hit or miss. Okay. Oh, maybe this is like impossible. It might be impossible for you guys to see. Maybe make the piece. I'll make PCBWay. Well, sorry guys. You guys are still there, but we need to. This is serious business. Okay. All right, so we need to look for U7, U6, U5, and then U8, and then U3, and then the last one, U4, is, I think we don't have to do anything. We have to flash something. So the other ones we don't have to, I think. So let's look. U7 is what? Okay, U6 and U7, we could populate both of those because they're the same. So those are, according to the bomb, 74 LS 138 1 of 8 decoders. I'm not sure what that means, but maybe it's some kind of like address decoding. So let's look in my bag of gear. Got to find those chips. Find the chips. Oh, wow, first one. First try. So all we should have to do is just plop it into the socket. Whoop. Okay. If we had more time, I would like look up what these things are, but I think it's some kind of a, I don't know, I'm not sure. But the interesting thing is, I think there is a floppy controller IC, or there definitely is, but there's not that much, not that many ICs involved with having a whole floppy controller for a whole computer. I mean, that seems crazy, right? I mean, it's possible that that is a highly integrated chip thing. Okay, so U7. Oh, this might be a little too. I'm just off screen. You can't see me doing it, but I'm like, kind of like folding the legs in like this to make them more square. So when they come in the bag, they kind of aren't square. Okay, so put that in. Whoop, crunchy. See what I'm talking about? They're like splayed, kind of out. Okay. What about U2? Oh yeah, U2. Okay, we'll get back to that. That's another what are those called? PLCC. We'll get there. Okay, so U5 and U6 or U7 and U6 are those decoder things. Okay, so those are the same. Now what's U5? U5 is a 74 LS 68 or 688 magnitude comparator. Don't know what that is. I just know it's a chip that we need to put in there. What did I say it was? U5? Yeah. Hey, look at that. Actually, U5 might be one of the ones. Oh, why there's so many? I think it might be one of the ones that is also on the. I had to order some of these. I forgot, which is why I couldn't do the streams back to back. But I had the flippy boot and some other, or flippy drive and some other things in between, so it was fine. But I had to order some things, so I couldn't do the stream back to back. And I think it was one of these parts. Because they're shared between the, well, not shared, but like they are the same part on the BOM between the floppy controller and the XT-CF card. And they must have messed up somehow in the BOM when I ordered the BOM. Okay, so let's put these other ones back. We just need one. Oh, gosh. We just need one for the floppy drive controller. Guess you'll proceed with or without U2. I don't know what you mean. Is that a trap? I'm kind of skipping over a lot of stuff. I'm just doing the easy. Skipping over, I mean skipping around the BOM. We'll get to all the parts that we need to boot it. But I'm just doing the easy stuff first. Okay, so this guy is U5, and that goes there. Okay, cool. All right, so let's see if we can find the clock, which is U8. So we'll kind of like work up. Now this needs to go aside because I may need it. What is this? Hotback flash thing. XT-U5. U3? What did I say it was? Oh, U3 is this thing. Okay, what's U3? Are there any special... Turn on carrot browsing. Get the heck out of here. Are there any special... maybe this is what I get for not reading carefully. Are there any special notes? Kind of. Not really. What did I say? U3 is what? Okay, U3 and U5. Wait a minute, what? Oh, huh? Wait a minute. Oh, it's the serial driver. Why am I in the wrong spot? Oh, okay. This part of the BOM is for the socket. That's why I'm like, huh? What is happening? I thought they looked like they were the same. Okay, U3. Okay, this is a serial driver. So this is what this long skinny thing here, which I just happen to have it handy. So let's just do that next. This is what makes the serial port work. Just making sure to line up the chips with the moon shapes. I'm trying to make a joke about, oh, with or without you too. I get it. Nice. Now I get it. I had a YouTube iPod. That's, does that age me a little bit? Not in like a bad way, but just when I was a kid, that's what I had. Okay. U4? Okay, U4 is the EEPROM, so we'll get, or the is it an EEPROM? Yeah, it is. So we'll get to that in a minute. So that's a side note because we need to flash that. All right, let's just do U2. What's another U2 song? Bloody Sunday, I guess. That was a terrible. All right, so U2 is this cool looking PLCC. It is pretty neat. What is it? Let's read. What is U2? U2 is a PLCC 44 package. Okay. Is this something I have to program? What is a 1655 UART? Oh, okay. So it's a UART controller. I'm hoping. Let's just look at the part. Is that what this is? A UART controller? I'm hoping. I don't think we have to flash it, right? UART interface IC. Okay. Let's go to the data sheet quickly. Is a universal asynchronous receiver and transmitter UART used for serial data communication? So this is part of the serial port. Okay. All right, so I'm guessing that this is just not, this is just a thing that we need to install. Okay, so here's the socket. We need to find the cut edge, which is this one. PLCCs are kind of funky. There's 3 corners that are sharp, and then there's one that's cut off. So that's the cutoff corner is like the key. Now we need to find the key of the socket, which is the bottom left. So like this. And then we're just gonna shove it. Boom. Nice. That was satisfying. I've been waiting for a while to put that in there. All right, cool. All right, next, back to the bomb. All right, let's see if we can find U8, which is the oh, here it is. The oscillator, crystal oscillator. This has a pretty neat what is this holder thing? Socket. That's what I'm trying to say. Holder thing, socket, you know. Get out. Okay, wow, look at that. That's neat. Cool. Okay, so I'm just going to put it so that the text side up. I mean, I don't think it has a certain way that it goes. Although it's possible that it does, but I'm going to put it in like this. I got to make sure that all the pins go in the socket. Well, did I need to cut those or anything? Okay, that seems kind of tall. Let's see. Can we look at the photo? I don't know. There's no profile of it, so it seems kind of high up, but that's right. Hey, Artemis. All right, we're gonna go with that. It seems very high off the board. Maybe I should have clipped those pins. Okay, what's next? I think we only have one more thing, which is before the EEPROM, and that is U1, which is somewhere. Is it this thing? Oh yeah, this bad Larry. See, let's look at the bottom again. U1. I bought the recommended one, the National Semiconductor PC8477BV-1. What's cool about this, let's get it out of here. It has a date code on or it has a copyright code at least, copyright date of 1991. So does that mean that this is from 1991, this part, or this design? It's pretty interesting. So this is, again, this is another PLCC, and we have to look for the cut off this edge, I suppose, and then it goes into its socket here, the same way. Boom. Wow, that was satisfying too. Okay. All right, so now all we've got to do is the EEPROM. So let's get that out. EEPROM. EEPROM. All right, I guess I can do away with the bomb for now, because we have to go over to the computer, kind of. Let me find it first. So the EEPROM is where the ROM is going to be stored for the, like the BIOS, like it's not BIOS, it's kind of like a BIOS, like it's sort of like a driver, sort of. It's like a hardware thing. Well, it loads software into the operating system or into the computer. So this particular one is an Atmel AT28C64B, which is I believe is the recommended one on the bomb. Let's see. No, Atmel AT28C64B is the recommended part. So we've got that thing. Now we need to find the BIOS files, or the Yeah, the BIOS, whatever, the code that we got to flash on here. The firmware, sure, that. So maybe I need to download the GitHub. Let's go over to the, here. So I just downloaded the whole GitHub project. Let's unzip it. Or extract the whole thing. Sure. Then let's travel in here. Firmware. Okay, so there's a binary file here. Okay, fine. So this binary, this 2.2 firmware, is what we've got to flash. So to do that, I have this. I showed it the first or the second stream, I suppose. The one when I flashed the EEPROM for the CPU board. I have the. Let me go to the overhead here. This is the program that I've got. It's the XT-ECU Pro model T48. So this is what I'm using, and it has this cool ZIF socket thing. So basically, the top is, let's get this out of here. The top is down. So there's a label here that tells you where the first pin should be, and it's down here. So we need to find the first pin of the EEPROM, which is there. So I need to orient this like thus. I know this is really, I'm like holding the cable in my other hand. That's why I don't have two hands. Do that, and we put it in the socket, and we put it down. So I'm not going to show that more than once because it's going to be the same thing, just lifting that up and down. But I will show the software that we use to program it. So that's just the hardware part, right? So that's how the socket, the chips go into that. But now we've got to open up the XT-ECU, or let me see, what is it called? Put that away. We have to open the XG Pro software. And it's actually pretty easy. It seems kind of intimidating. I was a little intimidated at first, but it's not bad. And if you watch the other stream, then you'll know too. Let's put my PCBWay sponsor. There we go. So what we need to do first is we need to find the IC. So we need to find this Atmel AT28C64B. So you can just type that in. AT, what did I say? I just forgot already. 28C64B. And usually if you don't typo, it comes right up. Atmel is the manufacturer, and then we have the thing. So we select that. And then we can do a read, which is just going to like have the XG Pro, whatever it's called, software, be like, hey, does this thing exist? Oh, that's at least what I do with it. So yes, it exists, which is good. So it says read finished and reading flash succeeded. So that's good. So we go back. Now we need to go to load. So we got to load that binary file that we found before. Then we need to go to downloads, which is where all my stuff goes. And then we need to go into the repository that I downloaded, and then the firmware, and then this binary file. So click that, and we click OK. Now we have to click program, and then we cross our fingers. So the chip is in the reader, the programmer, I mean. We're going to hit the program button, and then we're going to hit the program button again, and we're going to cross our fingers that it's just going to work. Succeeded, yay! Okay, so that's it. That's as easy as it is. Just you have to find the file. Excuse me. Select it in the software. Select the right chip, and then that's it. Done. Now we can take it out of the thing. I'm going to bend the pins a little bit so they fit in the socket. I did label the. Maybe I should put a little label on there. I don't know. I put a label on the one that was the BIOS for the CPU, just so I know what BIOS version was on it. So I could do that, but I don't know. Let's actually see for ha-has. Well, I guess there was an update 7 months ago. So maybe this changes enough where, I don't know. Maybe it doesn't really matter. All right, so now let's go to the overhead again. And that's the last thing we've got to do is plug this bad boy in there. Boom. Yeah, sweet. Nice. And that is one completed floppy controller / serial thing. Actually, you know what? Let's look up. We need to look up what JP1. So there's a jumper here, but I don't know what it does. So let's scroll down. Oh, let's go to the website. Look for that jumper. Okay, JP1, connect +5 to pin 3 of the floppy interface. This jumper is only required by some IBM PS2 floppy drives that lack a separate power connector and use pin 3 for 5 volts. Do not install it in any other case, as it will cause a short circuit. So I'm not going to install it. I'm not even going to put a jumper like on one of the pins. So you don't want to be tempted to put that on there, because I'm not using an IBM PS2 floppy drive. All right, let's bring over the micro 8088 and put it on the bench here. Let's check out what I've been doing. All right, so this is the temporary, I suppose, case, because I did buy some beige ABS filament. So I will be reprinting this all in beige, and I'm going to use the there is a little giant cup of scotch. Yeah, imagine that. This is a huge cup of scotch. Yes, this stream would never finish. There is a little micro 8088 thing in the front here. I didn't have a 2-color printer at the time, so I just skipped it. But I will be printing this in beige, and then I think I'm going to do the micro 8088 in black. So I ordered some Bamboo Labs ABS filament, so I'm going to try that. I've never tried that before. What's kind of interesting about the ABS or the Bamboo Labs filament is it's actually not, because normally I normally buy Polymaker, because it's sort of okay price, right? Like $22 a roll, depending on what you get, maybe a little more depending on the type of filament. But the Bamboo Labs filament, it gets cheaper the more of it you buy. So I ended up buying 2 rolls because I had to buy something else too. I had to buy the it's like an AMS bypass thing so that I can use an external roll. Okay, so anyway, so all this will be reprinted in beige, which is cool. So let's talk about what is in the case so far, right? So I kind of took it a little bit apart so you could see it more. So we already talked about in the first set of streams, this is the CPU board and its backplane. So this is kind of like the computer, right? Then all the other free slots for the backplane are for our expansion. Now again, ignore this card here, because this is sort of like my cheat code that allows us to like move ahead without first making the graphics card board. So I will be making the graphics card board that is in the micro 8088 sort of like project or whatever. But I don't have it yet. I have the chips, and I don't know. I just figured like baby steps. Let's talk about the storage before we get into the. So this is just a ATI VGA card, which is kind of cool that it's ATI, because if you know about ATI, it's sort of interesting that they made ISA VGA cards way back when. So ignore that for now. So then up here is the Pico power supply, which is kind of cool. So it plugs in, there's an ATX connector up here, there's a barrel jack connector there, and then the power supply is sort of off screen that you can't really see it. But it has a pre-connected little secondary connector, so that's for the actual power itself. It comes with this pre-attached, I guess, wire is what I'm trying to say. That is a Molex connector, so this is like permanently attached. Then it has a SATA connector also, but it also has a floppy connector. So I connected the floppy to this is my open flops. This is not a Gotek, but it's a Gotek clone, I guess. So I'm going to be using a Gotek for this system, but it's not going to be running the Gotek firmware. It's going to be running flash floppy firmware, which is way nicer than. We'll talk about that after we get this thing to boot. But we'll talk about what types of what do you need to put. It's a USB port, and you just use any normal flash drive. But we'll talk about how you need to prepare the flash drive, or not the flash drive. This is a flash drive, yeah, flash drive. So we'll talk about how to prepare that. So all you need to know right now is just this is a floppy drive. Well, I guess it's a floppy drive emulator, right? Okay. So we'll come back to that in a second. So now we've got to plug our floppy controller actually, before I actually commit it, well, I guess I could. That's why everything's kind of apart, is because this next part is kind of annoying. And also ignore this part too. This is just a button, like to turn the computer on. There is a button on the board here to turn the power on, but eventually there will be a little panel board. Actually, I have it. Don't tell PCBWay, but I used OshPark because it was just easier. So this is a little panel board that will have the power on reset and the activity LEDs and stuff. But for now, I just have this generic one that just has LEDs and a button on it. So that just lets me turn the computer on and off for now. So it's plugged in down here. It's plugged. The reset switch is plugged in on the computer board. That's really all I need to know so far. But we need to kind of shimmy some of it out of the way because the floppy controller, I kind of skipped a slot on the back plane because I want the floppy drive controller to be the top. I set the jumpers on the CPU board. I did. Oh, you're right, on the floppy controller. Yes, that's a good call. I don't really know what it should be set as. So what I'm going to try to do is I'm going to see what the picture is in the. We do need to set the. There's some configuration, switch configuration. So on the actual board, there are these two sets of dip switches. I completely forgot. Good call, Cooper. I don't know, like, huh? Why isn't it working? One set, it's written on the back what they do. There's little instructions, this white text, but we'll talk about it on the thing here. So let's read what it says. So it says, so let's talk about switch 1 first. I'll make this a little bit bigger. Switch 1 says serial port configuration. So this is not really make or break. This is not going to like blow us up yet because we're not using the serial port yet. Now I don't know. Let's look at the photo. It looks like 2, 3, and 4, or 2 through 6 are on. No. 1 is on, and 7 is on in the photo. So what does that mean? 1 is IRQ3 is the default serial, which means default setting for COM 2 and 4. See, I don't 100% understand the IRQ and COM. I mean, I understand COM from a nowadays computer where like you're setting a COM port to like connect to an Arduino or something. That's like the serial interface, I think, right? Even if it's through USB, you still have a serial connection to whatever you're connecting to. So like an Arduino or Raspberry Pi. But IRQ3, I don't understand. I know that they can't conflict too. You can't have like two devices that are doing the same thing. So if anybody has a good explanation of IRQ, I kind of know what it stands for. It's like interrupts, right? Interrupt something. But we're going to kind of cruise along. I'm just going to do what the picture said. So this is the default setting for COM 2 and 4 is switch 1. So I just, on the dip, on this thing here, I just set the first switch up here. That's what I was doing. Then it says, so that's pretty much, that covers switches 1 through 4. Like it gives you, basically it's choose one of those. Set yours to COM 1 default. Wait, so that'd be switch 2? Okay, so that would be, so if I want to switch it set it for COM 1, I would need to change, I'm looking at the instructions, so I need to put switch 2 on, which is IRQ4. So that's default setting for COM 1 and 3. Then I need to set the corresponding switch from switch 5 through 8. And I need COM 1, which is switch 8, on. I think that's right? Doesn't like have a default, which is kind of obnoxious. It doesn't really matter, but I trust Cooper, and this is going to be COM 1. All right, so now this bin of switches over here. I know a little bit more about what that is doing. It's going to set the address. We'll go back to the thing. It's going to set the address that the floppy controller EEPROM is going to load into. And that's important because we can't have two ROMs trying to load in the same address. IRQ is an interrupt request, and when the card needs to notify the CPU, it asserts the IRQ. So that's like like a hardware interrupt to the CPU. So I understand that, from, well, I don't really use it in my software developing stuff, but I understand that a CPU has a hardware interrupt that some software parts can say like, hey, you got to do this instead, or like if you have a mouse or something that has priority. Then special code or functions can be run non-interrupted when the IRQ is asserted. Okay, so it's kind of like a callback, like a hardware callback thing. Like it says, hey, I got to do this thing at this location. Yeah, okay, that's interesting. So the ROM configuration. So we've got to turn it on. So I'm going to not show you that's the wrong card. I'm going to not show you this overhead, but I'm going to do it. I'm going to talk about what I'm doing. So I want to turn switch 1 on. Switch 2 sub switch 1 on. So that turns the ROM on. That enables the ROM, which is good. If two items try to use the same IRQ at the same time, it causes a conflict and normally will end up in some lock state. Okay, that makes sense. Okay, so now we need to, I don't know if we want to turn EEPROM right on. It should be off if an EEPROM. So this is an EEPROM, so I guess that means we could turn it on. I think this is interesting because I did at one point have another XT IDE card that you could update the firmware from software on the computer. So maybe that's what this is. So you can you can flash a new, you know how we had to use the programmer to flash the BIOS or the firmware to the EEPROM once? With this, I believe, since this is an EEPROM, we can flash it again using software. We can update the firmware from software later. So I want to turn that on, I think. So the switch 2 sub switch 2 is on. Okay. Switch 3 through 7 is the ROM address. So that's what I need to look up down here. Now, I think I could just get away with the lowest one, right? I think so. Like, as long as we know, nothing else is loading. No ROM is loading. No other ROM is loading. Now, I think eventually we may get into trouble with. Sometimes there are video cards that have a default location for ROM that you can't adjust it. So that might come back to bite us. So I'm not sure. Maybe actually, let's start with at D1000. I think I know that that's what we had to do. The address of the cards is usually memory mapped IO, so you write to that address in memory. Okay, so the computer really it doesn't really know about the hardware, or the card, the expansion card. It just kind of knows, hey, here's an address. Do a thing to this address, and it could be kind of oblivious to what it's actually doing. Yes, you can update the flash ROM with the switch and leave that off unless it's flashing. Okay, so you want me to turn it off? Okay, that's fine. There's really no harm unless we negligently flash the BIOS or flash a firmware over that. What hardware? Oh, do you not have a floppy? Because I know you wanted one of those floppy cards, Cooper. Do you not have the floppy board thing? What address did you use, or what address should I use? I think D1000 is probably what I want to do. Let's check the photo up here. From this photo, okay, I think the switches are just kind of all over the place here. Oh no, look, it does have from this photo, 2 is on and 4 is on. Okay, so 4 is the first address, is it? Switch 4. Oh, I see, it's a decode, it's like a matrix. Okay, wait. Switch 3. Maybe I shouldn't be following this thing because it doesn't seem right. Oh, you have the dual. Okay. Think of it as an array, say like size 64K, and that index 2220 to 229 or whatever range is allocated. That data goes off to the card. Yep. Interesting. And that's what the not upper memory, but from, I think technically this era of computer, like you can have a maximum of 640 kilobytes of RAM, but then the computer can actually address from 640K to 1 megabyte. But those addresses from 640 to 1 megabyte are BIOS stuff, I think. I think that's my understanding of it anyway. So we need to fill, and actually when we could boot this up, there's this program check it, or there's actually probably a few that will be able to actually visualize where what is booted into what. So I'm going to guess, and I'm just going to do D1000. Well, okay. Let's just do the first one and see what happens. So that would be switch 3 needs to be on. Switch 3, switch 4, switch 5, switch 6, and switch 7. That gets us to the first address. So until we run into a conflict, we're just going to send it with the first one. I don't understand this. Off. Oh, there's another row of addresses over there. Oh, I see. So you could put stuff in here. So what would be off, on, off, off? It'd be 5600. So it's possible. Oh, it was off, on, off, off, off. That's EE100. These are hex addresses, so it's kind of a weird. I don't really know what I'm saying. I've heard people say like D1000. So the picture, I think, was off, on, off, off, off. That would be. Oh no. Off, on, off, 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 off. Yeah, because 8 is not used. So that would be this. So the picture is set at EE000. Really, computers are easy. So I'm going to set it just at C0000, whatever. That's the first address. So, oh yeah. Okay, look. It does actually mention here star. If there's this asterisk there, address range conflicts with EGA VGA BIOS. And then double star is E1000. I should have read this first, I guess. E1000 to EFFFFF address range is not available on the IBM XT. Well, this is if you're using it on IBM XT. That's reserved for the onboard BIOS extension ROMs. Okay. F1000 to FFFFF is not available on the IBM PC, XT, or IBM XT used system BIOS for reserved for onboard BIOS extension ROMs. Okay. So is C1000 in the danger zone? It is. Okay, so we're wrong already. So C1000 here with the star, that means there's a potential that it can conflict. So what I'm going to do is I'm going to switch. We're going to go to C8000, which is going to be on. So 3 needs to be on, 4 needs to be on, 5 needs to be off, 6 needs to be on, 7 needs to be on. Okay, cool. That should work. That should work. C1000 is for your VGA. Okay. Cooper's was on, off, on. C8000. Okay. Oh, okay. Perfect. That's exactly what I just did. On, off. Okay. Great. So I should have just I should have looked at the text at the bottom. So that's good to know. All right. So now we can go back to the overhead. Now we can actually install this. Whew. I know that the settings stuff is a little bit of a struggle, but that's right. Just because I'm not of this world. I'm not of this vintage manual address stuff. I know Pentiums and later was my upbringing. So oh boy, I don't love. Okay, let's get this. I need to do an adjustment. I might have to change this bracket out because I don't love it. I might have to print a different one. Let's see. Where's my screwdriver? Hello. Screwdriver. Where are you at? I'll just use this big one for now. Let me just make this guy big. So I have to undo this screw. I think it's ramming into it. Oh God. Oh, it's also possible that the 3D print is sort of not for this card. Yeah, this is just sort of a generic 3D print piece. It sort of works, but it's a little long for the case. You can kind of tell that it sticks out farther than the other ones. So the other ones are good. I got lucky because they're not really. There aren't. Well, actually, no. This one is in the CPU repository. There aren't 3D printing brackets in the repositories for the. Oh, here's my stinking thing. There weren't brackets, 3D print brackets, in the floppy controller repository. So I had to find. I think I just had to find a generic one for the serial port. But we could try to put a screw in, or should we just send it? Let's just send it. Okay, so let's put this up a little bit. Put this up like this. Now, I need to connect. I still need to connect a ribbon cable from here to the floppy drive. It's got the power. I kind of showed earlier. I've already have my floppy drive is powered up. Not with that, with the floppy connector here. So I just need a ribbon cable going here. I do have a twisty boy. It's just a 1-to-1 or one, there's not 2 on here. It's kind of long. I mean, I might have to get a smaller one or something, or make a smaller one once I get further along here. Actually, I don't know which way is 0. The unfortunate thing about this is it doesn't have the little nubbins, right? It's not keyed. Send it. I have a metal mounting plate, Cooper, but did you cut yours yourself? Or they're off-the-shelf ones? I've not done all this in 40 years. I have to relearn all of it again. It's really fun, actually. Like, you struggle with some things, and you learn way new things. Not new things, but you learn things that might be new to you. I mean, if you're my age, I'm 34. So, I wasn't even born when this sort of stuff was here. You thought you'd never have to deal with non-PNP again. Yeah, my mistake was having my parents get rid of stuff, my old stuff. I don't know which I know that on the cable, the red, at least this cable, the red wire is an indicator of pin 1. But there's no, I mean, the notch is supposed to mean something on ribbon cables that have notches, though, and I don't have one of those. So what we could try to do is, I think this, and I also don't have a, it's also not notched. So I'm going to plug it in first. The flippy side of my ribbon cable is going to plug into the open flops first. Then, and what I mean by flippy side is there's actually like a turn in the cable, and I think that's important. I think that's important for something. Now I have to guess which way around this goes because it doesn't have the notch, but I kind of do see somewhat of a notchy part. So maybe it does this. Maybe it needs to go that way. The cool thing about the open flops is it will yell at you if it's backwards. It kind of knows, and it can say, hey, just flip it around. No, it's the same as the one for the VGA. Mauser has it. Oh, okay. Interesting. That's good. Yeah, that'd be nice, Cooper, if you could send me that, because I can get one. All right. We're almost ready to turn it on. Let me kind of do this. I kind of want to show the screen of the floppy drive now, because that's kind of interesting. Okay. It does have a little OLED little screen readout. What we need to do is we need to plug in the power. Power goes to that. Okay. I don't know why that you said LEDs flickered. And then I need to plug in my VGA. I kind of have, oh gosh, turned off my light accidentally. I have stuff all over the place. I need to plug in my VGA cable that's going to the RetroTink 4K. Oh, gosh, okay, sorry, I'm kind of struggling right now. Okay, let's kind of screw those in a little bit so they don't go anywhere. And then, last but not least, is I have just a normal PS2 keyboard. Oh, that was the other thing. I didn't mention it, but I did actually get the PIC microcontroller, and I flashed because I was having trouble. If you go back to the CPU stream, where I was flashing the stuff for the CPU, I mentioned I couldn't get the PIC for the keyboard to flash. It just kept saying failed, whatever. So I ordered another one, and I just tried again earlier today, and it worked. So, and the keyboard works. I kind of pre-tested it. So this works now. The keyboard works. So let's plug the keyboard in, and you can kind of just like look at the keyboard notch, and it does just barely fit into the bracket. But red stripe to the front of the computer, not to the mounting bracket. Okay, so that's correct, right? Red stripe here. This is the front over here. Unfortunately, the VGA card that I'm using is so long that I can't put the front on. Okay, so the red stripe is pointing to the front. Okay, so let's kind of do this, and then I have to get my keyboard. Like, this is ridiculous. I just have so much crap. Well, I don't really have a. I wish I had another little table. All right, wait a minute. Hold that thought. I do have another one downstairs. Hold that thought. I'll be right back. I need to go get a little table thing to put the other keyboard on. Wait a minute. I'll be right back. Like 2 minutes. Okay, we back. I got this little thing. It's just a little so that I could put a second keyboard on it. There we go. Because I have my pull-out desk for my stream, and then okay, cool. All right. So now I need to plug in. Well, let's just send it. Let's turn it on. So that's what I have got my cool little button for. Actually, I'm gonna get the RetroTink output going. Gotta change the output. Did this all reset? I'll just preset it to. Oh, actually, you know what? I'll preemptively turn it off and back on again, the RetroTink. Then when it comes back up, got to change the input to HD15 RGHV. Boom. All right. But let's see what the open flops does. There's a little screen here, and it's going to be kind of, well, it's going to be kind of upside down for you guys. I'm sorry. Let's turn it on. I got my button. Whoa. Okay, open flop says ribbon cable may be upside down, question mark? Okay, so that, I think this side is fine. I think it's talking about the open flop side, this side. Okay, let's try it again. Oh, there we go, flash floppy. Okay, cool. So, oh, whoops, sorry. It just says flash floppy now. So, if we switch to the capture, you're just going to be able to see it's counting up the RAM. So this is basically not really doing anything yet. But let's see if it detects the, oh, press F2 to run a multi-BIOS. Okay, so I need to do the Oh, I hear a click on the. Oh, it's seeking. Okay, wait a minute. I gotta do something on the retro tank. I gotta go to advanced settings. I never remember where this is. Processing, scaling, cropping. Oh, here we go. And then I gotta do a full crop, auto crop. There you go. Now I can read everything. Sick. Look at that. It's detecting 400p, 70 hertz. That's cool. Okay. All right. So now, because we have no drive in, hard drive in, or floppy drive. Sorry. Let me do this. Video capture device. Oh gosh, why is it inverted? Hold on a minute. Well, shoot, you know I don't want to do that. Well, it's re-inverted. So that's fine. You guys will actually be able to read it, sort of. Let me move it over a little bit. Okay. So there's no disk in there. So it says boot failed because there's no disk. So that's fine. That's good. But it looks like it did also. It's good that it detected our the floppy drive card, right? So it says multi-floppy. So this is at the bottom of. So I'm looking. Oh, you guys can't see. Wait a minute. So it says total conventional RAM in the middle there, 640K, and then right below that it said found BIOS extension ROM at C8000. So that's good. That's perfect. That's what we wanted. Oh, let me turn off that. Okay. But then it loaded that driver. So the driver that we loaded is from 2013. Wow, that's crazy. And then it's looking at floppy disk controller 1. And then it's looking at our drive. So we've got our drive working. So what I want to do is I want to turn it off. Now I'm going to plug in the flash drive, and I'll just show you this first. So we know the thing is booting, but when we turn it back on again, so I turned it off, the computer. Now I've turned it back on again. If you look here, why does it say that? Boot. Boot. That is not what I expected. Oh. I don't know why it did that. Did I use the wrong... Oh my gosh, you know why? Because this is the wrong flash drive. That's dumb. Okay. I tried to keep it color-coded, so like IBM blue, so this is blue. That is why. Okay, here we go. All right, so now, using the flash floppy firmware, we get a list of all the files on this. I know this might be hard to see. Is it hard to see? Probably is. It's a list of all the files that are on this flash drive, all the floppy images. I'm just going to say that I'm going to go all the way over to I have MS-DOS 3.3 disk 1. Okay, so that's on here now. So now let's restart the computer. I guess we could do any key to try again. Let's try it. Did that do anything? F2 to run multi-floppy configuration. I think it's just stuck here. Let's restart. Found your COM1 correct and your drive correctly. Okay, good. Back in the day, was the floppy was always red striped to the power connector. Okay, so it's loading the RAM again. Loading our booting OS. Oh, I hear some seeking happening on the open flops. It's very slow, but that's the power of the 8088, I suppose. I don't know if you guys can hear that. Can you guys hear that clicking? Let me get it close here. Oh, look at that. So this is because we don't have a real-time clock, right? We have to set the current date. Ah, okay. So eventually I will have to do the real-time clock card. So today I'll just put, it just doesn't really matter because it's going to forget this as soon as, wait a minute. Oh, I was using the wrong keyboard. Maybe that's why I couldn't restart it before, as I was using the wrong keyboard. Okay, so this is 05-29-24. Oh, this is Y2K invalid. What does that mean? What do you mean invalid date? 05. Does it really not like the fact that we're in 24? What about 85? What? This is not Y2K approved. Okay. Well, time is relevant. Does this mean we're in DOS? We're in DOS. Hey, 4-digit year. Oh, okay. Got it. You can just put a 4-digit year in there. Nice. Very cool. All right, so let's see if we can load. So now, I believe, now that we're in DOS, we should be able to change the disk, the floppy drive image. What is happening here? We should be able to change the floppy drive, or the floppy in here. So let's see if we can get Checkit to load. So there's a program called Checkit. XT-CF Checkit. Okay, Checkit. Dir. So if we type in dir, that's gonna, oh, whoops, I didn't. If we type in dir, that's going to tell all the files that are in our drive, our floppy drive, because they're already on in the A drive. So now if we just do Checkit, I think we can just run Checkit. Or will this work, or we have to install? Do we have to install? Or can we run Checkit? Oh, this might not be the bootable one. Let's see, do I have a different one? Oh man, it might be on another man. Okay, we might have, this might not be a version that we can just run. Just for ha-has, I don't know what's going to happen, but let's do install it. Oh, scan? What does scan do? Oh, we got some seeking happening. Okay, so at this point, DOS is running in memory, but it's not actually installed on the computer. Yeah, so like if we restarted the computer, we would have to reboot into DOS. Does prompt work in this DOS? I mean, what do you mean prompt? Ooh, oh my God, is this going to take a very long time to load? Oh yeah, look at that loading bar. That is awesome. Authentic 8088 loading bar. We'll just see. This might take a long time. I don't think I have another program that I have on here that we can try to run. I didn't get this far ahead. All right, so let's check it. It was just an app that we could try to use to get some stats about the PC, but things seem to be working now. So for now, so the floppy controller obviously works. So that's really good. I'm excited about that. I'm not going to check the serial port now, but that's something I could do, or we could do, in order to make sure that all the functionality on the card works. But let's turn our attention to the XT IDE, or the XT-CF, I mean, because we can bang out a lot of that work tonight too. So goodbye, computer. You worked so well. Woo! That was exciting. So that means our soldering worked for that, which is cool. All right. Are you running 4 megahertz? It is on the lower 4 megahertz mode, I believe. Prompt $P $G. Well, sorry. We'll have to do it next time, next stream. But we do need to do some soldering. So now that the floppy controller is working, we need to get some storage. So that's the way that we can load DOS is with the floppy drive initially, right? And that's actually for the I just, you know, let me just because it's sort of interesting, right? So there was 3 different IBM PCs. Let me just, if you go to the IBM personal computer, right? Let's see if there's going to be like a nice, maybe this. Doesn't really give a good picture. But let me just search 5150. All right, let's Google IBM because they have these code names. 5150 is the first one. The well, not the first, but it's called the IBM PC. So the 5150. Let's see. Is there a good photo of it? I guess this PC Mag one. It had no hard drive. So well, I have my AT in the basement, but it also has 2 of these. So these are also what's called. Let me see if I can make this bigger. This is what they used to call full-size drives. Is that they're actually double height of what we think of as like a 5 1/4 drive. There are actually 2 of those on top of each other. So the original IBM PC came with 2 just floppy drives. So you could store an IBM or a DOS disk in one of them, and then you could use the other one to load your programs. So you wouldn't have to like swap out your DOS disk. You would just kind of leave it in there all the time. But the problem is you can write updates to the floppy disk, right? So there are some games that actually save their own save data to themselves, to the disk, the floppy disk. But for most, if you're familiar with a computer nowadays, you store stuff, your operating system and your save files and stuff is on a hard drive. So the original IBM AT computer did not have a hard drive at all. It wasn't until just like, I don't know, maybe it was like not the right time, or it was expensive probably. So the IBM 5160 is what people call the IBM XT. Let's see if we can get a picture of that. Here, I suppose. Well, that one's kind of a weird layout. Well, maybe it was like this. So let's just open this one. See if we can get a good photo. This? Okay. Is this an XT? Yeah. So this is an XT. It actually only had 1 floppy drive, but it has, if you look on the right, it had space for a hard drive. So this is the first. So this is the second IBM PC, but it was called the XT. Had the same processor. Had the same 8088 processor. So this is the one that had a hard drive. So now basically our computer right now is kind of like an IBM PC. It has the floppy drive that we can switch. We could take the disk out and put a different one in, but we don't have any way to store data. So we want the IBM XT. We want to XTify our our clone IBM. So funnily enough, I think that's sort of why the XT is called the XT. I don't know. Maybe it's just because it's an 8-bit. I used 1 disk drive for DOS and OS utilities and swapped the other disks for programs and stuff. Yep, that's cool. Single-sided 360K. Okay, so we need the XT for a bunch of reasons, but mostly we need to. It gives us the ability to store stuff on a compact flash. So it's not a hard drive, but it's a drive, but it's compact flash. But it's kind of the same situation. We don't have anything plugged in, or anything is put into the hole. So let's do that. Actually, you know what? Before we do that, we need to solder this. Let's solder this guy. That means I need to get my because we haven't done any soldering tonight. I need to get my. Is something gonna explode? Hopefully not. I need to get my microscope over here. Okay. Let's move my drink out of the way. Let's see. That's already on. Let me turn on the camera. Microscope. Hey! Whoa, it was raring to go. No problems of the past. Windows XT. Extended technology. Okay, so we need to solder the compact flash connector. Where's that? Another bag. In the box that I moved over here. Yes, indeed. This guy. Oh, taped up and everything. Let me turn down actually the that. Actually, I need to turn off my overhead camera too, or overhead lights, because that usually adds glare. Okay, turn on the soldering iron. Okay, just trying to, I'm mucking around with the settings. All right, so let's get our connector. Oh my gosh, look at this beast. That is crazy. So there's our CF connector on the top here. That's where the CF pins would connect. I'm hoping, I think I can get away with not having to remove the bracket. Let's see. I guess so, right? Oh, look, there's actually, this is going to be easy because there are, let's see, there are little nubbins. There are. If you look kind of closely here, there are little pegs. Right, so these pegs line up with pegs on the board. On the, oh, forgot I gotta focus. On the board there. So like, this literally is gonna be pretty easy mode. So you just kind of line it up so that the pieces fit in the puzzle. I'm going to avoid, there are ground pads up here on this side and then one on the other side, but I'm going to avoid soldering them. I'm going to solder the pin, at least like a pin on this side and then a pin over here to tack it down. Norton Commander was pretty good for moving around faster in DOS. Interesting. Oh, I don't have bolts. I don't think I have the hardware. Desk View, Tanimate. So there's a lot of cool DOS programs that you guys know of that I have no idea about. So there's easier ways to get around DOS. Sort of like there's no GUI. Well, I mean, I'm not going to put Windows on. There's no Windows. Because Windows, like even Windows 3 was for like a 386. Okay. Let's tack this down. Let's get my solder is way over here for some reason. Okay. Okay. then I guess I'll tack something down over here. Oh, actually, you know what I need? I need some liquid flux. Some liquid flux down. Okay, that's fine. There's a bridge here. But that's all right. I just want to tack it down so it's not going to move. So now I think we could probably tack down the big ground pads over here. Right, so there's one. Two. Okay, that seems right. We can always touch that up afterward. Let's see. Should we try a different type of tip? Maybe not. Maybe I have a J tip. That seems like it might be good for this. I gotta straighten it out. Okay. Cool. Okay, so let's see if we can fix this bridge. You know what's the part of the problem is my air conditioner is on. Trying to do some fancy drag soldering here, but all right, more liquid flux, more solder on the tip. Let's try it. It's not working too well. I've never soldered this type of connector before, so I have a feeling that we have way too much solder. So let's get some solder braid. You know what? I might actually switch back to the chisel tip. Yeah, maybe that. This is like not even. I guess I'll have to. Let me turn my air conditioner off. The problem is it's blowing right over the top of it, like right over the top of my table. And I have a feeling that might be cooling it down. All right, so we can go one by one, but let's do this first. Let's get rid of this solder. Try not to melt the connector. Okay. Let's just go one by one. I'm at 350 C K-tip. Yeah, I'll have some more flux. Well, the problem is these pins are so huge. Problem is I think I don't have enough solder on here, you know, now. See, that one's nice. You know what I want to do? I'm stepping it up. Stepping it up. Stepping it up. Hey, Ian, by the way. Saw you post. I'm going to use some of this VS213 Amtech flux. Probably a ton. Oh, God. Did you see that? Pepperidge Farms remembers. But the problem is, if you get too much on here, it's like impossible to get off. It doesn't wick away. Like if you have an IC leg that does that, you can usually pull it off by drag soldering, but man, this is brutal. All right, we're making it. I think I might need more heat as well. Try that. 380? Is that too much? Maybe that's my problem. Oh yeah, there we go. Look at that. 380. Ah, see? Did it again. Do. Skill issue. Yes, this is definitely a skill issue. That's funny. Well, it's always nerve-wracking, at least for me. I don't know about you pro solderers in the stream here, but soldering a new thing, different thing that I've never soldered before, it's always like, I don't know, my brain blows up. Hey, this is not bad. Just this part here. Okay, so let's clean up that bridge. We're making progress. We're melting the connector. No, I'm just kidding. I hope not. Okay, that's good. Plus, is this thing here, I'm probably melting it. Do you guys see this cap that I'm melting? Hopefully not. Okay. Let's go down. Go down the line. God, the bridges. Jeff Bridges. Okay. Gotta fix that, but let's keep going. Use a bevel tip. Yeah, maybe the K-tip or something. Oh, God, really? All right. We did it. Now we just got to clear these bridges. Okay. All right. Nice. Anything we need to clean up? Let's, this is always the best time. Look at gross, nasty particles. I mean, when you zoom in close on stuff like this, it looks nasty. It doesn't look that bad. I didn't really melt anything that I could see. Well, that joint looks not good. Is that a big ground pad or something? Okay. What soldering station? I was too cheap to buy the what is it called? The JBC, the badass one that everybody buys. Everybody's been buying last year or so. So I was looking for clones of the JBC because I do like the tips, the whatever, this cartridge style where you plug it in, the whole thing in. So I bought a clone called the Aijun T3A from AliExpress. So it's been mostly fine. It has higher wattage. I came from a Hakko FX888D, which is only on paper like 60 or 75 watts or something. So I wanted something that could have more power for, I don't know, anything, for whatever. And so this is supposed to have 100 and something watts of power, or like, I don't know, 150 or 200 or something. I don't know. I think we're almost dry here, or cleaned. Then we could do the, I'll have to clean this better off camera, but we can try to speed run the rest of the install and see if it'll boot. And we can configure it and stuff, and then so it's been fine. I mean, it's a budget soldering iron. The only thing I had to do with it is I had to super glue the handle. So we can kind of tilt it and try to look at the. Oh, we can zoom in even more. Look at that. As long as we have a good connection there on all these pins, I think we'll be fine. I did lift some of the like here you can see I lost some of the I heated too much and lost some of the what is it, the solder mask, but I think we're good. Just as long as there's no bridging visible, at least. I know there's a little there's liquid in here from the IPA, so it's hard to tell that if they're bridged or not. Ideally, I probably would hit this with the my multimeter, but I think I left it downstairs, so rip. We're just gonna send it. All right, that concludes the soldering portion of the stream. That was fun. You have the KSGER T12 that still works nice. Nice. Yeah, I kind of went over that one because I know the KSGER is still kind of like the Hakko caliber, I think. I'm not sure. I don't know. I think it uses the Hakko tip, the different style Hakko tips, not the one with the FX888D. The problem with that is the screw-on things that you can't hot swap. But at least with this, the Aijun, it has, you know, these tips that you can just take off like this. So like if I want a different tip, I could just yank it off and then I put the new one on. So that's worth its weight if you have it. Just, you know, there's a lot of different irons that can do that. Just, yeah. All right, let's put the other chips in. the ICs, and we'll try to program the EEPROM also, because that has the XT IDE stuff. Oh yeah, it's like literally a clone of the. It's kind of a different color. I think the JBC is green, but this is like the same thing. Yeah. I mean, someday I want to get one because I do like quality things. But I figured for the first one, okay. So I need to load the BOM for the XT-CF. That's what I'm doing now. In the background. Okay, cool. So, all right, I think U3 and U2 are the same situation as the before. So we need to find U3 and U4, which I think are the same, those magnitude comparators. I think that's the same. Let me, you know what I didn't do? Let me do that too. I don't have a mouse that has a back button. That sucks. I gotta load the floppy drive BOM. One of these has the same chip. Oh, I can turn my air conditioner back on too. Okay. This 74 LS 688 is U5, which is U3 and U2 here. 74 LS 688. So I didn't add the reference designators to the bag, but I had 3 of them, and I only needed 1 on the other one, so that's how I knew. I'll show you what I mean. These parts are the same as the floppy drive controller U5, but I didn't put. I ordered 3, but I didn't put the label. So these 2 chips here are the U3 and U4, U2 and U3. So I'm just going to straighten the pins. You can get fantastic deals on military industrial surplus Metcal gear. Interesting. That's cool. I've heard Metcal brand before. I don't necessarily need anything right now. This is fine. I mean, I was getting really annoyed with this station. Hold on, I'll show you in a second. I was getting really annoyed with this station because there's a seam here between like whatever this part is and like this bottom part, and this is where like the wires go through here and they connect to the top here. There's a glue here from the factory. It was coming unseparated, so like once in a while, because this gets hot, it just melted the glue and it just came separated. And I'm like, this thing's gonna fall apart. So I super glued it. I don't know if that was a good idea or not, but yeah, I was about to throw it out because I was frustrated with that. But then I'm like, okay, I'll just super glue it and move on. And it seems to be fine since then. So cool. All right, so there's U3 and U2. Now, what else we got? We got a U4, which is a 74 LS32 quad 2-input OR gate. So let's find that. Not that. Found it. U4. My Hako, oh, you had is that the fancy one, the 936, predecessor to the FX? Oh, the predecessor to the FX. Oh, is that the one that has the 888D? Oh, the non-digital one has like an on-off, has like a manual dial. It doesn't have like a digital readout for the temperature. It's like a physical dial. Maybe that's what you're talking about. Yeah, I guess I had no complaints for a beginner. I had no complaints with my Hako. I like the colors. That's actually where my Discord colors come from. I like the Hako colors, but nowadays I have nothing Hako because they're so expensive. Like their high-end soldering station is like JVC price or more. Okay, so this is for U4. This is that quad 2-input OR gate thing. Goes in here. All right, now U5 is a 74LS04 hex inverter, or multiple of them, I guess I should say. This might be some of the ones I had to rebuy more of, so I've got another little baggie. Oh yeah, look at that. First one I picked out is U5. It just says a dial. That's pretty cool. Well, maybe not cool. It probably has a hard time. Do you have a hard time like picking the right temperature, or like an exact temperature, or you just kind of wing it? Well, when it sounds like you replaced it. You're tempted to get the JBC style. Yeah, I mean just for the fact that you can swap out the tips, and you can use real JBC tips, which is they're really high quality. They're really expensive. I want to try not to grab them because they're probably hot, but some of these are knockoff ones. Like that's a knockoff one. But my chisel tip one is a real JBC one. Like they're very, oops, drop something. They're very high quality. Like I beat the heck out of them. I mean, I haven't had them that long compared to the Hako, but I mean, I don't maintain them. I just beat on them, and they work pretty well. Okay, so the last thing. Oh, I also wanted to note too, while we're looking at this, you'll notice that R5 is a resistor. This is supposed to be not populated. So we go back to the window and we look at R5 on the BOM. Here it says note, do not install. And it's actually the same in the picture. There's a picture up here. It's not populated there. So just an FYI, if you said like, if you looked at my thing and you're like, hey, why don't you populate that? It's because they tell you not to. So yeah, the soldering could be better. It's hard to get the flow right, like because if you have too much solder, they're going to go up into the pins. And I guess my initial problem was not enough heat. So, all right, so now we've got another EEPROM. So we need to flash another EEPROM. Oh, I guess some of this stuff is for that. Oh yeah, for the button board, this board. So that's for another day. But that will let us, well, when we have the VGA card, so I can get rid of the long one that I can actually put the front of the case on. I can use these buttons that actually are in the front of the case to turn the computer on and off. So now we need another EEPROM. Not that. Here it is. I need to flash the XT IDE BIOS. So this is another one of those same exact ones. So we shouldn't have to set anything up in the flasher. It should already be selected because this is the last thing we flashed, which is handy. But I think I have to download the BOM on this computer. So if we go back to the window, you get what you pay for when it comes to tips. Yeah, absolutely. Yeah, you can just kind of tell. I don't know. Just I'm sure they're fine. I'm looking at a clone one. But yeah, I don't know. And if I ever get a real JBC one, I just wanted to have. All right, so let's clone. Let's get this repo. And then we can extract it because we're going to need the BIOS from it, which is in firmware. There it is, IDE XT. I know if you go through, there's a whole XT IDE website that has like all the stuff about the universal BIOS, and so we're not going to cover that here. But there's a lot kind of involved with the XT IDE project. But just know that for the purposes of this computer, that this is how we're going to let the computer have storage. So it's a little more complicated than that, but yeah. Okay, so let's go to the XG Pro software. I guess we could do a read on this chip just to make sure it's fine. So finished, read finished, fine. Now we've got to load the new hex file or the bin file. And the downloads there, firmware, IBM XT. So I guess what I was trying to say is if you can go to the XT IDE website, and they do have a big list of all the different versions of the software, because there's ones for the AT, there's different versions of the same thing, different firmware versions for this project. So this is the one I think that we want for this card. Now we can hit program. I'll get some water. Oh, programming succeeded. Yay. Cool. Making good progress. All right, so now we can take the EEPROM out. Now we've got to configure. There's a couple of dip switches on this. Gotta bend these pins. I'm glad that some people in the chat that have experience with these IBM PCs are here, because, you know, I do love learning about them. I'm just getting a compact flash thing to get ready for the next part. I love learning about it, and like it's hard, you know. I sort of binge watch Adrian's Digital Basement. Like that's one of the only channels. Well, I guess and to a lesser extent LGR, but you know, I personally sort of learned by osmosis. Not Adrian is like an incredibly good debugger. Like if like a fault finder and stuff, like hardware fault finding, I suck hard at that. So you know, I just watch him for entertainment. But so I have my CF card in here. But I just love learning about it. Like I just wish I was better. And I don't know. Maybe when I'm older, I'll have more time and patience to sit down and learn some of those debugging things. Okay, so let's figure out what we have to do for this. The switches. So I'm gonna pull up. Okay. I/O address selection. So there's two sets of switches. There's a little tiny one and the longer one here. I/O address. I noticed that it's different. Huh. All right, well, let's skip the first one for now, because that seems sort of like the IRQ stuff. But I'm looking at this set of switch 2. I know for a fact that we want to turn switch 1 on, because that's enabled the EEPROM. As far as write enable, we can leave that off, because I don't think I'm ever going to flash a different BIOS on here unless it doesn't work. But then we need to look at the 3 through 7. So this is the same as before. Same as the other card, similar to the other card. But we need to do, how much higher do I need to go? How big are these ROM, these memory locations? How big is we put the other one at C8000, right? Oh, it tells you lower down. Okay, wait. Addresses C1000 to C6000. Oh, let me turn to this. C1000 to C6000 will conflict with the EGA VGA BIOS extension. So we knew that from before. C8000 might conflict with the XT hard drive BIOS extension. Okay, so we don't want to choose that. E1000 and up might conflict with the system BIOS on newer motherboards. It's recommended to disable EEPROM write once the XT IDE BIOS extension is programmed and configured. Okay. Do we need to program it again? I didn't think we needed to do that. Okay. I don't really know what we need to select. I guess I'll do D1000, because that's far enough away from the C8000. So what we need to do, so that would be 3 is on. Let me 3 on, 4 off, 5 on, 6 on, 7 off, and 8 does nothing. So that sets ours for D1000. Now, but as far as these memory these IO address locations, I don't know what to choose there. I guess I can Google that. Oops. What the? I have to look over my camera. Sorry. Okay, so we want to let's control. No. The heck? Let's look up IO address selection. IBM. Oh gosh, IBM XT. Sure. Oh, determining what IO address. Oh, this is just a forum post, but I don't. Why is IO different? Why is this different though than the other? Right, like this is the floppy stuff. It was talking about IRQ. Oh, this. So it's like COM ports, sort of. It looks, the address looks similar, right? Oh, but it's like above it. No, it's different. Huh. What does the picture look like? Everything is on. So it just chooses the first address. So switch 1, subswitch 1, 2, and 3 on. I guess it doesn't really say why. What does their second bank look like? On. So their XT card is set for on, off, off. So that would be on, off, off. CA1000? D1000? No, so I did D1000 too, but what about the first one? You need to search for IDE. I just never heard this lingo before. Okay. All right, that's fine. I think it probably would make more sense if I could visualize it through like check it or something. But I would like to do is to see if I can get this to do anything. 300 should be fine. Okay, let's just send it and get our computer back. We'll try to boot it. We're gonna have to put it kind of far down in our stack now. I guess what I could do also is, now that I don't need to show you guys the hard drive, I'm going to go a little bit over tonight. Let me see if I can get my floppy. Oh, this is kind of hard to do. The camera's in the way. Hold on, I'll show you what I'm talking about in a second. Okay. Get in your home. So that 300, that IO address or whatever, that's different than like DMA and IRQ. Just don't know what it means. Switch 1, 2, 3 are all on. Okay, so that's 300. Yep. Okay, now the computer is kind of together. Oh gosh. I'm crushing stuff. Well. Let me take this back off again. Abort! Sorry. I was trying to screw this lid on the computer, but eh. Get it out of here. We have so many things now, so much room for, not a lot of room for activities. Okay, so let's do that. Let's see what we've got left open in our the computer here. It's kind of crazy. We're starting to run out of ports. So what do we have left? Sound card, VGA card, which is here, so that's fine. Sound card. Now our XT IDE or XT-CF card. I guess I'll just put that. I don't know, next for now. And then we'll need a sound card next. I do have some Pico Gus's, but I think I'm going to build an ad-lib, standalone ad-lib. I think that these ain't going to work. Uh-oh. Okay, I need to remove this. I don't understand that. The corner here. Okay, well, let me take this cover off. Okay, I'm trying to speed run to the end here. Just want to see if there's any conflicts or anything. I don't think we'll have time to install DOS, but oh, we could do. What's the command to prep the disk for DOS for installing stuff? Okay, so that's that. I'm going to kind of leave it down, but let's plug in our stuff. Here's our thing, okay, that. Let's plug in our VGA card. What's odd? RS matrix. Oh, the bracket, yeah. I guess I don't know why I didn't realize it sooner. Why it has the there's a thing there. F disk. Okay, maybe we can run that, right? That's to prepare the disk for DOS. What else we need? Keyboard. Over here. I think that's the only command we need to run too, right? If I'm not mistaken, there's no like format thing because the DOS install takes care of that, I think. All right, I think we've got everything. Got my, it's kind of hard for you guys to see, but I'll be able to see it. I'm gonna choose my DOS disk here. So let's get the capture going. The notch on the bracket is odd. Yeah, I didn't even think about that. You had to plug yours into a modern machine and do a clean and disk part. Okay, interesting. To format the drive, the CF card. All right, let's power it on. Where's my power button? All right, I need to find DOS, MS-DOS 3, disk 1. Yep. So we're just gonna do 3.3. I know there's other versions of. Oh, see, this is probably. This is what happens to. I don't know why it happened now. Sometimes. Well, actually, maybe it was a conflict with the or something with a conflict. Let's see. All right. I had to restart the thing. Change the thing to the thing. If you use DOS install, it will format it for you. Oh, okay, on DOS 5 and higher. Okay, so we might have to do more manual stuff with DOS 3. All right, let's try it again. Hello? Oh. What is that? Can't read it. Okay, well, let's try. Maybe we'll have to do a... Okay, we're getting some conflictorinos, right? So if I take the CF card out, either that means that maybe there's a problem. Let me take the disk out. Let's try it without the compact flash disk in first before we do anything. Let's try it again. Do. If we get some weird video. Oh, okay. Maybe there was a. Let's see if we get the XT-ID or the XT-CF, XT-ID BIOS, whatever, detected. Maybe I do have a bridge. Yeah, see, XT-IDE or the XT-CF thing should be booting now, shouldn't it? Or maybe it does it later. Oh, actually, you know what? I should go back. I think is it aux 4 or aux? Oh, there it is, aux 2. Huh, so that is weird. Is there something else that I'm missing? I did just totally send it. So it's perhaps a conflict? Let's turn it off and let's try a different address. Let me just look at the documentation. So ours is set to what? On, off, on. Oh, it said to delete that. Oh, okay, I forgot an on. I don't think it really matters, but because it was higher than that. On, off, on and on. Okay. You should have the XT-IDE BIOS. Yeah, that's why I'm like, this is probably not working. Did I forget something? I'm just looking at the chips. Making sure they're all connected all the way down. Could try a different slot. I did try a different slot. I'll try another slot. All right, let's try that. It matters if you are in the BIOS space of the VGA card. What happens if you hit F1? Welcome to BIOS. Hello, help. Nah, let's get out of here. Well, it's possible. Let me see if I can run it at D8000. Let's try D8000. I think we might be running into a conflict with the VGA graphics card BIOS. So that would be on. So I'm moving up to D8000 from D0000. So on, off, off, on, off, off, on. Okay, so now we're in another section. Another memory address. Let's see. Try that. Boot. Do. Oh, I could run that. Let me see. I do have a. Okay, wait a minute. Okay, so keep in mind, I'm on D8000. D8000. I do have. Thankfully, I have this. There's a disk image called. All my buttons is kind of sticky. It doesn't really work. XT-CF So let's try to boot that. No. Oh, we have to boot into DOS first, huh? Forgot. So we need to boot into DOS. Go, DOS disk. Okay, we're getting there. DOS loading. This is XT. I think the XT part of this whole retro system stuff is the best and worst part because it's always hard to configure in the beginning. I had the same experience with another computer that I had. Okay, let's see what's on here. Oh, that's the DOS. That's DOS. Never mind. That's going to show me all that. All right, let's load a different disk. Need to go to that XT IDE CFG. What do we got? Okay, so now we need to load XT IDE CFG. All right, let's see. Oh, that's true. Isn't there some? There's something that we have to load. Okay, let me see. So we have to. I think we have to go here, load BIOS from file, and then we have to select. Well, thankfully I have all this stuff on here, and I don't know which one we need. XTP, XTPL, XTL. I don't know which one we need. Let's just try the biggest one. Port 300 in the ROM address C8000. Okay. I think we could switch it back after we do this, but I think. Okay, so let's see this. So we gotta load. BIOS is not loaded. Okay, here we go. Successfully loaded. So this will change the menu. Now we need to configure it, right? This. Oh, I think I do need to enable the right. Okay, I need to power off, right? Do I need to power off, or can I enable the EEPROM from here? So I do need to actually enable that that write enable thing to set up XTID. Wow, the VGA card is warm. I think that was the second bit. Turn that on. On. Okay. Sorry, I have to do this all over again. So I've got to load DOS again. We're getting there. We're getting there. So let's go to DOS. DOS. So we gotta wait for this to load. Skip memory. Skip. Oh, escape. Skip. Wait for it to load. Okay, are we almost there? Boop, boop, beep. Beep, beep, beep. I like the beeper. Okay, skip the time and date. Now we can go back to the XT IDE disk. There it is. XT IDE CFG. Let's just run XT IDE CFG. Okay, then we need to load. I don't know which one of these. I don't have the exact BIOS. I wrote this floppy image. Custom wrote. Well, I didn't custom write it. I had it load all of the different binary files here back when I was doing my stuff on my 386 and 286 stuff. So I don't know which one of these versions of the XT one that I need. I think I'm just going to go with this biggest one. So that was that. But then it takes a second to load the image or the BIOS file. Then it changes the menu so that we can configure the XT IDE. Oh, primary IDE controller. I don't think we need to deal with that, right? Auto configure, sure. #0 controller is fine. We don't need that, right? I don't know what we need to change. But I know what when we do flash it, it does change something. Oh, generates the checksum byte. I think that's what we need. But we need to change the address to D8000. Come on, man. What? D8000. Huh? What the heck? That? Is that what it wants from us? Okay, I guess that's it. Now we need to know what EEPROM we've got. We have a 2864. Yep, that's correct. Okay. I think this is right? So obviously we don't have any. We don't have any XT IDE stuff or IDE controllers. Number of floppies, scan for serial drives. Oh, this? Okay, don't change that. All right, let's just try all the default stuff. I don't know what to change in that menu. So let's try to full operating mode. No, we don't have 4 controllers. Do I want to set this to 0? 1 to 4. Okay, don't change that. Oh man, device type. Did you write the BIOS to the micro 8088 CPU card? I got rid of it, Cooper. I reverted that. I didn't mention that. I should have actually. So I wrote, when I originally did the CPU card, I wrote the version of the BIOS for the CPU card that included XT IDE, but I didn't want that. So I didn't want that for this video. Or this stream. So I reverted that. I'm just gonna leave it all the default. I don't know, 16-bit. I know that's incorrect. But I don't know which one of these is. I do see this XT-CF here. It's possible that the version of it's possible that I need to write the specific BIOS that is in the thing. I don't think I can finish this now. I think I have to write the specific BIOS that is included in the repository. I think I want, okay, let me see. Go back. Where was that menu again? This, device type. This one. Let's try that. Sure, okay, that changed a lot of stuff. Okay, master drive. Yada yada. Okay. Internal write cache. Okay, that's fine. Let's just leave that all to default. Sweet. Okay, look at that. So it was kind of, this changed the menu here so that we have a lot less things. So the base address is that 300. So let's see that if that works. Okay. So now we've got to go to flash. The address is correct. Yep. Sure. SDP, I don't know what that is. Generate checksum byte, yes. Start flashing. Let's try it. Image is too large. Okay. So we've got to load on the smaller BIOS files. Oh, hold on, guys. 1 second. Oops. All right. Okay. I think I don't think I can finish this. Well, actually, let me see. Uh-oh, what happened? Oh, here we go. I could try this one. Or one of these smaller ones, right? Because that was kind of huge. Let's try the X. Okay, so this is all set again. All right, let's just try this. I don't think there's any harm in doing this. Woo! It's working. Sweet. It's flashing. This might be the wrong version of the BIOS, but... Oh! Oh! What happened? It rebooted. Why you do this? Okay. Things are happening. Is it going to do the XT IDE right after the mem test? FTC1. No, it didn't seem to have done anything. Okay, well, I think I've got to flash a different, get the other, that all right, I think the problem, I guess, I got to wrap up because I got to go. I got to bring my dog out and I got to go to bed and stuff. Thank you, PCBWay, for sponsoring this video. I really do appreciate it. I would not be able to mess around with this stuff, even though it's kind of out of my comfort zone. But I like that. I like, I like being able to have you guys show up that are way more knowledgeable than I am. Kind of give me, sometimes spoon feed me stuff, but like it is really a good experience. And I think I like doing these streams in the way that I do them because a lot of people might have the same exact struggles that I do. And I kind of try to play, I talked about this before, I kind of try to play like an idiot, sort of, not play, but I am an idiot. I try to record being an idiot, which is, I think it's like a genuine struggle, like the genuine struggles, because I think if somebody is going to do this and they come across my streams, they might find, that valuable and how to do this. So just to kind of wrap things up, I think I have to, that XT IDE configuration utility is used to, you can write versions of the XT firmware to the EEPROM from software. That's kind of what I was talking about a little bit earlier. Way back when I was doing this for my 286 machine, I prepared that floppy image that was on this card with all the BIOSes that I could get right from the website. So it has all different versions for 286 and whatever. It doesn't have the specific version that is in this XT-CF Lite repo. So it's possible that there's something in that specific firmware, that specific XT firmware that I need for this card. So I'll have to prepare another image. I can't remember exactly how I did that, but I'll figure it out. Using the XT-CF program, get the binary file that I need in here, and try to flash it again. But that means we'll have to do it on another stream. I'll show that process because that might trip up people, so I want to make sure that I capture that moment that I succeed at that. Because, yeah, I remember it being kind of fiddly. All right, thanks again, PCBWay. Thanks again, everybody watching the stream. The next stream is probably, I don't know, it depends on how I'm feeling. It might be this again, just to try to bash my head against this a little more. But I I know what we could do. I think maybe we could mix it up, and I could build these cool Tamiya kits. So I have these two. The reason I bought these is somebody suggested I use these tools. It's a actual like model kit, right? If you ever built a plastic model, like a Gundam or something, Gunpla, sorry. You have to build this, but it's an actual tool, like a little tiny Dremel, and I'm hoping that it's quiet enough that I can use it on stream. And if so, if I succeed with these, if these tools are quiet enough, I will do I'll attempt, I suppose, the loopy capture mod for the 3DS internal capture mod. So my goal is to have these tools be able to be useful for cutting the plastic on a 3DS. And if that's the case, then I'll do that mod on stream. Well, I will be doing that mod on stream, but whether or not I cut the plastic on stream is the deciding factor. So yeah, definitely going to be doing the video card as well for the Micro 8088. So cards that are left for the Micro 88 saga. Like I said, I want to finish this project before Retro World is a convention in Hartford, in Connecticut, that is coming up in a couple of months or something, I think. And LGR is going to be there, and so I'm hoping to bring this completed system to have him autograph it. That would be that's my goal for this year, is to finish this project, have it working. I don't know how I'm going to show him it working, but I would like him to sign it, because that would be really sick. Because yeah, that would just mean a lot to me to have him do that. So that means I got to hurry my butt up and finish everything. So what's left in the Micro 88 build? Obviously, getting the CF card working. We still have more cards to build, so I need the actual VGA card. There is a VGA card in this sort of thing, so I can replace the one that I'm using now, the ATI card, with the smaller one that fits in the case. There's also a sound card, which is not a Sound Blaster, but the other AdLib. So there's an AdLib sound card, which is it's the XT. That's the generation, sort of the generation of that. So AdLib. Then there's also the real-time clock card, which would prevent me from having to set the date and time every single time, I believe. So we can do that one as well. And then I'm not sure what else there is. Oh, I guess a network card would be sick, but I'm not sure, because then we could boot up. There's actually certain web servers that people set up that you can access, like bulletin boards, whatever, that you can access through XT class machines. So that'd be really cool to be able to connect to the internet on this computer. Oh, the OPL2. Okay, so there is a more sophisticated sound card. It's not just AdLib. You're hoping to make it to Retro World. Dang, I hope so, dude. That'd be cool. I mean, I will say, I've gone the past 3 or so years, it is a small, as far as I know, I haven't really been to any other retro conventions. It is a smaller convention. So there's plenty of stuff to buy and stuff to walk around, but you will get through it in a day. It does go on for 3 days actually this year. Friday evening after work-ish, and then Saturday, Sunday, all day. But in just my experience, unless you're going to stay for panels and things, because there are panels on both Saturday and Sunday days. So like Bob is going to have a panel. Usually he has a panel. Tito comes usually. So Tito will, he's definitely going to be there. So they'll have like a Bob. I'm not sure what the panel is going to be, but like the last kind of years, it was just like general talk about modding stuff. So that's, it's worth the trip for that alone. Just to talk, ask kind of AMA style, ask Bob and Tito stuff. And then LGR is going to be there, so that's cool. And so, but what is good about it being small is that you're more likely to meet those people. Like, you can very easily, hang out, not hang out maybe, because sometimes there's like dedicated time slots to like do meet and greet stuff. But usually there's a lot of sections that aren't. It's just kind of like free for all, and they usually stick around their tables, and you can talk to them and stuff. So that's really exciting, stuff I can do. 64, telnet to BBS. Oh, telnet. I guess not. We're not connecting through a web server. It's like telnetting to a BBS. Yes. Is that the difference between a BBS? You can't connect through HTTP. You have the telnet there. Interesting. So just want to see the homies. Yeah, Steve. Oh, yeah. Is Steve coming this year? I'm not sure. I didn't see the RetroTech. I didn't see the thing. So, all right. So there's still a ton of work to do. We got to get this card working. And then I still have box of mods and stuff. Box of mods I haven't done, and yeah. So thanks again. I talked forever, even though I said I wasn't gonna talk forever. Thanks again, PCBWay, for sponsoring the video, and we'll see you on Sunday with something different.